So dear students, in this video lecture, we are going to continue periodic analog signals. In this, we are continue about analog signals. Already we know this lecture outcome. So after listening this all three videos, you are able to sketch the periodic and non-periodic analog signals, and also able to calculate what is the frequency of the signal and phase of the signal and bandwidth of the signal for the given scenario. Okay. So what is composite signal? As of now, what we are discussed, what is analog signal, how to draw the analog signal, what is periodic signals, and the simple periodic signals, what is the phase, how we can calculate the phase value, how we can calculate the periods and frequency. So those things already discussed in the previous video. So in this video, we are going to discuss about composite signals. What is the composite signals? That means it's compressed with multiple symbol signals, that is considered as a composite signal. Okay. So in this video, we are going to discuss about the remaining part of the first video. The composite signals, a signal frequency sine wave is not useful in data communication. Okay. In single frequency sine wave. So what is that? If in case it is the medium, okay. So this the medium is there. So the only single wave it is there. Okay. So if you are sending only one wave, what is the useful of this medium? So it is carrying only one signal means it is not occupying entire capacity of the cable. So it must be sent with composite signals. Okay. So we need to send us a composite signal. The signal made of many simple sine waves. So already I said, so many waves are there that will be composed into small values. So that is considered as the composite signal. According to Fourier analysis, any composite signal is a combination of simple sine waves with different frequencies, different amplitude and phase. Okay, I already said. So this is the different amplitude, height of the waves, and different frequency. Number of waves or periods are different, and phases also different. So here, periodic composite signal means can be decomposed into a series of simple sine waves with the discrete frequencies. The frequencies that have integer values, we know that what is the value. Okay, the frequency is 1 Hz, 2 Hz, 3 Hz, like that we can say. But non-periodic composite signal means decomposed into the combinations of infinite number of simple sine waves with continuous frequency. Okay, so frequency that have real values, it is not integer values. So here you can see this difference between the composite periodic signal. So this is a signal, it's carrying the composite signal. How we can draw this signal? So see here in this pink color, this is the high amplitude. What is that amplitude? How much? What is the frequency of this? Only 3 cycles are there. Okay. So here up to this 1 cycle, up to this 2 cycle, 3 cycle is there. So 3 cycle means frequency is 3F. Okay. So then blue color line, you just calculate how many thing is there. So totally this, how many cycles are there, that we are saying about it. Up to this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 frequency are there. So then, so actually this diagram is, they are given in wrong manner. How we can draw this? Normally, blue color have three waves. Okay. So then we can say this 3F with pink color, that is the highest amplitude. Then 9F. Okay, so the blue color have 9 periods. So it's have the less amplitude. So then black color, how much it is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 F, that is the black color, is very less. So like that we can mention the frequency domain. In time domain, how it is going, that non-periodic signals. So the periodic signals continuously it is varying the amplitude. Okay, it will be the difference. So in frequency domain, how we are represented? So it may be from starting frequency to up to what is the total frequency. Okay, so like that we can mention it. So what is bandwidth? The range of frequencies contained in a composite signal is its bandwidth. The bandwidth is normally a difference between two numbers. Okay, so which is the highest frequency, which is the lowest frequency, we have to find from the difference between the highest frequency. What we have to write? Bandwidth equal to highest frequency minus lowest frequency. Okay, so this is the formula for finding the bandwidth. So example, if the bandwidth, the frequency of the signals between 1000 to 5000, or if bandwidth equal to 5000 minus 1000, so bandwidth equal to 4000. Okay, so highest frequency is 5000, lowest frequency is 1000, then frequency is calculated. Okay, how we are mentioning that periodic signal in the bandwidth? This is a periodic signal. The signals may be vary from 1000 to 5000. Okay, because the lowest frequency is 1000, the highest frequency is 5000. In between, any number of sine waves may be transmitted. Okay, the example I'm saying that this is a 1000. Okay, so 1001, so 1002. Like that, if any number value up to 5000, it may be there. Okay, up to 5000, it may be there. So how we can draw this? So 5000 is the highest value, 1000 is the lowest value, so the bandwidth is 4000. That means how much capacity of the cable is used for transmitting the signal, that is the bandwidth. Okay, that's the capacity of medium. So here they are given, see here, already shown this. If a periodic signal is decomposed into 5 sine waves with the frequency of 100, 300, 500, 700 and 900. Okay, so you see the 5 signals are there. The frequency is 100, then 300, 500, 700, 900. So like that, it's a different frequency with a different amplitude is there. What is the bandwidth of the bandwidth of the signal they are asked? So what is that minimum value? 100. Okay, so 100 is the minimum. Maximum is 900. So what is the bandwidth? 900 minus 100. So total 800. So 800, that is the bandwidth of the particular signals. Okay. So in case if you can, what they are asking, draw the spectrum assuming all components have the maximum amplitude of 10 volt. So it is a periodic signal now. So the volt is common, maximum is 10 volt only. Okay, but the wavelength is different. It may be 100 to 900. Okay, so we can represent like this. So finally we are finding 800 kilohertz. How we can represent? 10 volt only, maximum 10 volt. So we can keep 10 volt. In 100, 300, 500. 5 signal waves are transmitted now. This example, so you see here 5 values we are given. So we can draw the bandwidth of these signals equal to 800 kilohertz. Okay. The next one, what's a periodic signal is a bandwidth of 20 hertz. The highest frequency is 60 hertz. Okay, the highest frequency is 60 hertz. What is the lowest frequency? So 60 minus 20. So lowest is 40. What is the lowest frequency? Here find it. Draw the spectrum if the signal contains all frequency of the same amplitude. Okay. So how we can calculate? 20 hertz is there. Okay. So already they are given signal bandwidth is 20. So it will start from what is the lowest frequency? 40. What is the highest frequency? 60. So the 40 it will start and 60 it will end. So what is the highest frequency? The amplitude? It's all have the same amplitude they are given. So it may be example, assume that value is 5 volt. So you can say 40, 41, 42, 43, 44, 45, 46 up to 59, 60. So this is the non-periodic composite signal bandwidth of 200 kilohertz with the middle frequency is 140 kilohertz and peak amplitude is 20 volt. The two extreme frequency have an amplitude of 0. Okay, so extreme is 0 they are given. So the amplitude is 0 means 0 to 20 volt it may be changed. The middle amplitude is 140. Okay. Then what is the kilohertz they are saying? 200 kilohertz. Okay. So you just assume that if they are given 200, okay, total is 200 kilohertz. So what they are saying? 140 kilohertz is the middle. 140 is the middle. So 200 means here this side 100, this side 100. What is this? This side 100. You have to minus 100. Here plus 100. Okay. So 240. So that only they are given. This is the minus 100. This is the plus 100. Total 200. What they are saying? Extreme stage is 0 amplitude. Okay. So middle is the highest amplitude is 20 watts. Okay. So this is the 20 watts. So we can represent non-periodic composite signal in the frequency domain. Like this, we can represent it. So finally, we are conclude periodic analog signals. We are able to know and we are able to understand what is periodic signal, what is non-periodic signals, how we are converting the signals, what is the frequency, what is the phase, and what is the wavelength of the signals. Everything we are discussed in this lecture. So now you are able to understand and are able to sketch periodic and non-periodic analog signals and also able to calculate what is the frequency, what is the phase, and what is the bandwidth of the given signals in a given scenario. Okay. So now sample questions are given, you just try it and come for discussion. Sketch the analog signal which have 8 hertz frequency and 18 volt amplitude. So how you can draw the signals? 8 hertz I told and frequency in frequency and 18 volt I told. Only amplitude and frequency I given. I'm not given timing. So how you can draw? So 18 volt means this is 18 volt. Okay. So 8 frequency means 8 F. So you can draw this point. This is frequency domain representation. Okay. Next, define the composite signal. Combinations of multiple symbol signals or multiple sine waves is considered as a composite signal. So finally, a periodic signal has a bandwidth of 40 hertz. The highest frequency is 80 hertz. What is the lowest frequency? So automatically bandwidth is 40 and the highest is 80. So highest frequency is 80 they are saying. Bandwidth is 40. Okay, so highest point 80 means minus 40. Okay, so what is the lowest frequency? Again 80 minus 40 equal to 40. Draw the spectrum, the signal contains all the things. Okay, so this is the minimum values 40. So maximum value 80, you can draw 40, 41, 42, 43, 44 up to 80. So thank you for listening all 3 videos. I hope you are understand what is periodic and non-periodic analog signals. Okay, the next video lecture we will discuss performance of the network. Okay, thank you once again.